Welcome to doassignment-ca. Here is the problem. A jet car is originally traveling at a velocity of 10 meters per second when it is subjected to a piecewise acceleration. The acceleration equals 6 meters per second squared for times from 0 up to 15 seconds, and then equals negative 4 meters per second squared for all times at or after 15 seconds. At time 0, the position is 0. Determine first the car's maximum velocity, and second, the time t' when the car stops. Now let's work through the solution step by step. The acceleration is piecewise constant, 6 meters per second squared from time 0 up to 15 seconds, then negative 4 meters per second squared after that. The car starts with a velocity of 10 meters per second and a position of 0. Integrating the constant acceleration of 6 from time 0 with starting velocity 10 gives v equals 6t plus 10. Because the acceleration is positive throughout this interval, the velocity keeps increasing, so the maximum must occur at t equals 15 seconds. Substituting t equals 15 into the velocity expression gives 6 times 15 plus 10, which equals 100 meters per second. This is the car's maximum velocity. For the second phase, the acceleration is negative 4. The car enters this phase at 100 meters per second. Integrating gives v equals 100 minus 4 times the quantity t minus 15. Setting the velocity equal to 0 and solving 4 times the quantity t prime minus 15 equals 100, so t prime minus 15 equals 25, giving t prime equals 40 seconds. As a sanity check, we compute the total distance. In the first 15 seconds, the car covers 825 meters, and in the next 25 seconds, it covers 1,250 more meters, for a total of 2,075 meters. The velocity was always positive until t prime equals 40 seconds, so the answer is physically consistent. To summarize, the maximum velocity is 100 meters per second, reached at t equals 15 seconds. The car then decelerates and comes to a complete stop at t prime equals 40 seconds. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.